Great. So let's get started. Good morning, everyone. Welcome to Conquering Cross-Database Join Talks. Before we get started, let's first introduce ourselves. My name is Dingding Lu. I am the product manager of Query team, who is responsible for implementing the backend query engine for cross-database join. I joined Tableau a little over a year ago. Prior to Tableau, I spent 7.5 years at Microsoft SQL Server team and 1 year at Nordstrom Information and Enterprise team. Now I let my colleague Dimitri introduce himself.
Good morning, guys. Made it okay here? It was quite a walk. My name is Dimitri. I'm a software engineer at Tableau. I've been with Tableau for about 3 years. Anyone remembers 8.2, the data source tab we introduced? That was the first feature I worked on. For the last year, me and my team have been working on cross-database joins, and that's what we're going to talk about today.
Great, yes. So we will allocate question time at the end of the talk. But if you have a pressing question you really want to pop up during our talk, please feel free to do so. And we will try our best to take as many questions as we can. All right, so this talk will all be about cross-database join. Our colleagues are presenting same or similar topics, such as blending. And we actually have a list of recommended talks for you at the end of this presentation for your reference. We expect that you have some experience using this feature already by building a data source using cross-database joins, or at least played with this feature. But if you haven't, no worries. We'll cover the basics in the beginning of this talk. We will first take you to have a deep look behind the curtain of how this feature is designed and implemented. We will explain to you why sometimes your join just didn't work or did not perform as you expected. We will teach you tips and tricks to turn your join around into good and faster ones. And we will then present the future of what is already on the roadmap, such that you can align the BI planning of your company or organization with what's coming soon in Tableau. So first of all, why do we need cross-database join to begin with? The short answer is we all know that data scattered around all over the places, and you just want to combine them. Imagine that you want to know how much of your market campaign helped with your last quarter sale. You have your sales transaction fact table in SQL Server and your product dimension table in some MDM system in Oracle, and other data scattered all around the places that you want to make sense of. Without cross-database join, what do you need to do? You usually need to submit a request to your IT department, say, please pull all my data into one place. Your IT department will put your request normally into a queue, and then you wait. After days and weeks, finally, they manage to pull the data into usually a single database. Now you can start connecting to it, use Tableau, and build your analysis. With cross-database join, you no longer need to wait. You just simply connect to all those data sources directly through Tableau and start building your analysis. In summary, with cross-database join, it expedites the process of data exploration and analysis by empowering users to gather data around all over the place through a simple drag and drop. Users no longer need to rely on their RT department and wait for them to gather and prepare the data for them. So what are cross-database join good at? As I already mentioned, that it's a great data exploration tool. It is not only useful for users who need to use the data and build a report. It is also a great tool for IT department to explore, discover, and understand the correct relationship between data before they build a permanent linkage for those data. Also, it does not require to extract all of your data upfront, then join. you have the flexibility to connect live and join live. Of course, you always have the option, as you have today, to take an extract of the join result and then proceed with your analysis. One key thing differentiate cross-database join from blending is you can publish your cross-database join data source to Tableau server and can be shared across your organization. Performance of cross-database join is quite pleasant until you have a really large data sets to deal with. We are talking about billions of rows and several gigabytes of data size. In such case, we generally recommend you take an extract. Maybe it still takes a little while for the extract to be generated, but everything after that is just as smooth as what you have today. And believe it or not, we have tricks and tips that we can teach you to speed up your joins while you still get the correct results for your join. And my colleague Dimitri will cover that in his part of the presentation today. So before we dive into the design details of this feature, we need to get our terminology correct first. We need to differentiate connections versus data source. Connections is a physical connectivity layer. Before Tableau 10.0, really, you have a one-to-one mapping between your data source and connections. So this is the UI you see. Before Tableau 10.0, you can see the one-to-one mapping before your data source and connections. So before Tableau 10.0, it's really those two terms, connections and the data source, are interchangeable without causing much confusion. However, with the cross-database join shipped with Tableau 10.0, now a data source can contain multiple connections. This is the UI you see when you connect to Tableau 10.0. In the example we have here, you want to cross-database join between Postgres and MySQL. Tableau established two connections to those two data sources. And the connection is listed under this new connection pane on the left. We also use color coding to differentiate between connections. As you can see, we use same color for connections, and everything, such as tables, fields, comes from this same connection. So how does cross-database join work? First of all, of course, you need to connect to all the data sets that you want to join together. And then it will happen in the 3 simple steps. In first step, Tableau sends a query to each individual connections and requests for all the data that is needed to process the cross-database join. In step 2, Tableau then brings all this data locally. Locally means to the machine where Tableau is installed. In step 3, Tableau uses something we call integration engine. As for this current version of cross-database join, we use a Tableau internal engine called Tableau Database Engine to perform the join. So the integration engine is the place where the join happens. One thing I need to point out is, cross-database join is performed on row level, meaning we will need to pull in every single row in order to process that join. And I also want to point out is that we do not pull in the entire row with all the columns. We will only pull in the columns that is needed, say to run your query, to execute your report, or to calculate the functions you put together. So at this point, you may have already guessed what might impact the performance the most. The data movement. So the more data you need to pull in to process your cross-database join, the likely slower performance you will get. As I mentioned that there are many ways that we can teach you to minimize this data movement while still getting the correct join results out, and we will cover that in the later of this presentation. So what can you do today? So what cross-database join supports is capability-driven, meaning it is not confined into a predefined limited list. It is actually determined on the fly by the intersection of Tableau data engine and all connections in use. In another word, for a calculation or join type to be supported by cross-database join, it has to be presented in every connection you want to join together, as well as Tableau data engine. For example, say I want to build a data source. I first connect to SQL Server. Not a problem. The 4 join type, inner, left, right, 4 outer join, are supported by SQL Server. Of course, I'm getting all those join types. Now, I add a table from Oracle. As you can see, immediately, Tableau data engine comes into play because it is the integration engine where the join will be processed. Using this intersection of capability concept, what cross-database join is intersection of what SQL Server supports, Oracle supports, and Tableau data engine supports. Luckily, all those 4 join types are supported by those 3 connections. Fine, we get all those 4 join types. Now, what if I add MySQL? Now you can see the 4 outer join become unavailable. The reason why is because MySQL does not support outer join. As a result, outer join type will not be in the intersection of capabilities, and thus it becomes unavailable. So now let's take a look at the capabilities supported by Tableau data engine, because this is kind of like the base set we will always be intersecting with as far as you're doing cross-database join. So calculations. Tableau data engine supports a really rich set of calculations, and personally, I have a hard time to find a popular function that is not supported by Tableau data engine. For join types, as I already mentioned, the 4 suites of join type are supported. We released left and inner in Tableau 10.0, and we add right and 4 outer in Tableau 10.1. And for join conditions, currently, we only support equality joins, but we are thinking about adding inequality joining in our roadmap. So now I will hand over this talk to my colleague, Dimitri, and he will actually show how this feature works in action. Dimitri.
Whoa. Thank you, Ding Ding. Nice refresher. Right on. Before we begin, quick poll. How many of you tried cross-database join? Show of hands. Wow, more than I expected. Keep your hands up if it worked for you or you find a good application for it, in terms of actually did a good analysis. OK. Might adjust some of my presentation for this, but probably we shouldn't have to. Before we begin, let's set the stage. For this demo, or for the set of demo, or for my part of the presentation, I prepared the data set that looks like this. I have an order information, customer information, some product information, and geographical data for granularity. And imagine it's spread all over the place. No fun, right? This is probably what you are dealing with on a regular basis. And now let me do a quick demo of how it looks. So this is my simple dashboard that I prepared a while ago. It shows me some information about my sales. And let's dig into that. I'm not a good viz builder, so it is what it is. My data set has about, well, exactly 500,000 records, just to kind of get a feel of what I'm dealing with. This is how it looks. So currently, I'm connected to Postgres, and I'm just joining 2 tables. What about everything else? As you can see right here, I have a customer ID column, and I know that my customer information is in MySQL. So let's connect to that. One of the things we did add is this tiny add button, which adds a connection into the current data source, not a new data source. You click that, you get a similar experience of list of connectors. You might notice some of them are grayed out, means are currently not supported. This is Mac. List is slightly smaller than you might see it on Windows. But I'm going to pick MySQL and just connect to it. So now I have two connections. One is to Postgres, one is to MySQL. Let's just add a table. I'm going to pick a schema and a customer table. So right now, it looks simple, but behind the scenes, Tableau pulled in the data from Postgres, pulled in the data from MySQL, and performed a row-level join on this data set. I can go a bit further. I can pick up an Excel file, drop it in Tableau. Because I'm on the data source tab, the file was added as a connection to the data source. If you would drop file on the viz, it would add as a data source. So one differentiation here we added to make it a little bit easier. And again, Excel file was just joined in. And now I can follow the colors from blue to orange to whatever that color is. And at the, which one? I would call it teal, but yes, close enough. And you can see at the bottom of the data, we kind of follow the same schema. I know that these set of columns are from Excel, this is from MySQL, and I can go on. We also support more complex things, like here I have multiple text files, and it's a break apart of my product by category. For whatever reason, I have that. I'm just going to drag in a file. Again, it's added as a new connection here, join together. Can go on the left side, select remaining set of the files, and just drag into this area, which gives me access to quick union creation. And just like that, I have, again, order, product information, and whatnot. I'm going to name it to products. So right now, I have a join of 4 different data sets, all in together or low-level join. And it's ready to be shared and published and reused. This is ideal case for this feature that we built for. So let's move over to, it's basically an introduction for a few of you that didn't raise their hands. So let's move over. Okay. So my next few of slides, they're going to touch on a subject that I mark as bad joins. By bad joins, I mean you couldn't complete your join, or a join didn't produce the correct result or result you expected. First topic I'm going to go over is join on null values. Imagine you have this data set, just 2 tables that I'm trying to join. And as you can see, so I'm joining on location code. For me, it's not set, it's empty, and I have a matching row in the description table. If you would do this join in most of the databases, inner join, you would get this result. So nulls are non-comparable in most of the systems, and therefore not going to be matched. If you do something like this in our text and Excel connectors, we would give you this result. As you can see, highlighted row was matched. So again, for text and Excel connectors, we treat nulls as equal. This is one big difference. I'm not sure how many people use that, but one of the things you would notice. With cross-database joins, we're adding additional set of rules. For a single connection before is what I mentioned. For text and Excel, nulls are equal. You can compare them, you can put them together. Everything else is non-comparable. Industry calls it ANSI null semantics. So starting with 10, we're adding you a new option that's available through data menu. So for text and Excel connector, you can change the behavior for nulls to be equal or not. If you would create a new workbook in 10 and join tables, text files, or join sheets in Excel, you would get ANSI null semantics, so nulls will not be matched. You can change it through the data menu. The older workbooks will preserve their behavior, so nulls would be treated as equal. What the point here is, for multi-connection data sources, we require everything to kind of conform to a single standard, and we're choosing to follow the ANSI null semantics. Nulls are not going to be comparable. The reason why it's in this set of slides is, imagine you're joining Excel sheets in 9.3. It's going to produce you one set of results. If you suddenly want to join sheets in 10.0 and start from the beginning, you might get slightly different result just because of some rows are not going to batch. And an extension of that, if you would join two different Excel files, will always force you to confront to ANSI and all semantics. So one little things to be watching out for. My main slide in this section is data types of joint columns. For people that try this feature, probably encountered that at this point. So as a background, before Tableau was very forgiving. It is forgiving now. So for single connections, we would allow you to join on the different data types. You can join number on a string. You can join a float on a decimal. If the backend can support it, we would allow you to do that. So this is one of the things that are capability driven. So most of the connection will give you that option. And we let the backend database handle the cast or handle the type matching for us. So for cross-database joins, we have to be more strict than before. We have to we can no longer rely on a backend to always do a casting for us, and we want to be consistent. We are not really able to match behavior of 50 plus connectors that are out there, so we want to just restrict that behavior to you have to explicitly match data types. So you cannot join number on string anymore. You cannot join integers and the decimal numbers, dates and date times, and I'll get back to it a little bit. Basically, bigger numbers. I'll get to that in a second. Actually, I'm covered. So one of the big reasons for data type mismatch that we saw from experience and from beta feedback from you guys is there are certain databases that impose a really, I guess, optimistic data type defaults on some data types. This is the bottom number. If you would pick an integer in certain systems, by default it says my integers are 38-digit wide with 0 numbers after comma. It's a very big number. Tableau doesn't know how to handle it as an integer. So Tableau is forced to bring it in as a floating point number just to allow for that 38-digit width. So Tableau sees it as a double, and when you try to put something like this, like integer from one system to a regular 64-bit integer, would say types are mismatching. So this is one of the things to watch out for. We're trying to figure out how to address it the best way without causing truncation issues and whatnot. How to resolve data type mismatches? So thing number one, for text, Excel, and Google Sheets, you can directly change type via type switcher. If you do that, Tableau actually reparses the underlying file or Excel sheet and brings in the data in the format that you specified. So these are only 3 connectors that do support that. We saw some confusion around that topic because typically when you change a type on the column when you're building a viz, it only changes the type on the projection. It doesn't really affect join key types. So the second fallback is custom SQL. If you're using the feature, that might become your new best friend, at least for a while. Basically replace one side with a custom SQL with appropriate cast in place, just to satisfy Tableau requirement for matching data types. I have to mention that if you're just started or you have an ability, design your environment for gross database join in mind. So avoid uncommon data types. If you're dealing with GUIDs or Booleans that are not uniformly supported across the board, try avoiding them and maybe find a substitute. Use 1 and 0 for Booleans or use bigger integers for GUIDs. And as a fallback, there's also an option of creating an extract of individual data source and then use resulting extract file as a part of the cross-database join. This opens up the possibility for you to join on calculations to adjust the types, just because those things will be abstracted by the extract. Yes, quickly. Correct, you're right. Yes, currently published data sources is one of the things that are not in the list. That's on we're going to get to that. To your point, managing extract files outside of the join and publishing becomes really challenging because you're disconnecting to like the data source that created an extract and the usage of the extract. I probably would say it's not sustainable, so I would only recommend it currently for ad hoc analysis. So if you really want to put something together, fall back to the extract. Otherwise, figure out how you. Go ahead.
Can you join to Tableau extracts?
The question is, can you join to Tableau extract? The answer is yes. Tableau data extract or TD file, just consider this like a regular connection. So you can drag and drop it into Tableau and do whatever you want with it. It's not explicitly listed on the connector list, but you can always click more and connect to TD file or just drag and drop file into Tableau. Correct. So the comment was about extract locally stored. The thing is, in our world, once you publish extract to server, it's not an extract anymore. It's a published data source. And client does not really care about what's behind that data source. It could be extract, it could be live connection. It's just a published data source. Other considerations. So additional things to watch out for once you step into the world of cross-database joins. Common thing is data mismatch. Since it's two separate systems or multiple separate systems, most likely they were not built and maintained with the notion of that you're going to put them together at one point. So you might deal with different format of phone numbers, different state with the 2 letters and full state names. Currently, in Tableau, we don't offer pre-join data cleaning or pre-join calculations. So there's nothing outside of like using custom SQL you can do to actually confront data to a same format. I think one thing we tried internally or offered is if you actually have a case of you have a 2-letter state and a full state name, you can build like a mapping table and put it in between your data sets if you really want to join something. Non-supported connections. So Tableau server is one of the big ones that we're currently working on to enable because it opened up the gates to individual extract schedules and whatnot. So if you see it grayed out, it's currently not supported. And to be honest, it's not supported for probably a good reason. Some of the connectors were more challenging for us to handle. It's a V1. We're just getting started. So if you have a connector you don't support, so consider using an extract and then join with an extract file. Connector-specific functionality. This is going back to intersection. So if you do have something in your connection that you really want to join or you want to use together, imagine a situation you have a 2 MySQL table and you bring in an Excel file and you want a full outer join on those 2 MySQL tables. Currently, it's going to be filtered out because of the intersection. Fallback here is, again, custom SQL. You can always abstract the functionality that you need from a given connection by a custom SQL. I'll try to show you an example in a demo real quick. And clean up unused connections. So again, to the intersection portion, once you add a connection, this is where we adjust your data source to support or not support anything. So don't just pile in the connections for future use. Keep the ones you actually have in your join and remove everything else. No per connection extract. Currently, there is no way to say, hey, I have a SQL Server instance and I have my Excel file. Only if you say create an extract out of this cross-database join will always require to bring in the fresh data from both. You cannot say only update MySQL portion of it. We typically saw it being an issue when people try to publish such data source on a server and try refreshing the server. They still have access to a SQL server, but the link to like Excel file is gone because they reference local file system on your desktop. So currently, you have to fall back to using maybe a file shares to point to an Excel file. Yes?
So if you create a data extract file that has multiple data sources connected, and you say refresh the extract, it's going to want to refresh all data like that.
The question was if you have a cross-database join that's extracted and you refresh it, yes, we'll pull in data from everywhere. You cannot say leave this data alone. If you have a great usage case, please submit the feedback. We need to prioritize what we're working on next. Cool. Demo number 2. Let's do that. Okay, second part of the demo, we'll kind of touch base on the last couple of slides. Again, I have my amazing dashboard that connects to pretty much same data source or same data set. Again, it's a safe 500,000 record. 2 Postgres tables joined together. There's a little difference here is, as you might tell from a table name, on the right side I have a table that has a different column times on the join. So let's see what happens when I add MySQL. So 2 things happen here as soon as I added MySQL connection. So one, we have a broken join that was valid before, and 2, we have a broken connection, broken calculation. Let's take a look at both real quick. So as calculation is broken, I'm using raw SQL. So this is one of the pretty much few or the only one that's in this cross-database join is not supported. As Ding Ding mentioned, Tableau data engine, which is used to determine the intersection, is really, really capable at this point. We did a lot of work to add additional capabilities that were not there just to support this scenario. So in this case, raw SQL pretty much was the only function I could find that's not supported. If you use it, I have no good workaround besides custom SQL for you. I'm gonna get rid of that real quick. So what happened here, we say there's a mismatch of join keys between a number, well, integer and a double. Before that, like if I go back, this Postgres is okay with that. Postgres can handle it. It pulls in data just fine. But once you have MySQL, we say, nah, we don't want to deal with that. So we say join is invalid. So 3 things you can do for that. One thing is I often opt out. Like if you're in Russia, if you don't want to deal with it, you can go say from the data menu, convert to custom SQL. What it does, it takes everything that you currently have in the join and makes a custom SQL statement out of it. As you can see, we just say it's an inner join, and Postgres will handle it. We're never going to break it apart. So this is coming back to if you want full outer join in MySQL, you would do something like this. So this is one of the one thing. The other part would be I can go and say, hey, add a custom SQL, and I'm going to type in, and I'm going to do the cast on a particular column. In this case, I pretend that I went back and actually fixed my data because having doubles for join keys does not make sense. I'm going to drag in my fixed table that has a proper join key, and I'm going to work around with this. So going back to MySQL, again, I'm going to pick a customers table. In this case, it's a customers with a huge integer. Is that case when I have a 38-digit wide number? So if I want to join in on that, again, I'm joining customer ID on a customer ID. Same problem. I'm joining an integer, what Tableau perceives as a floating point number. And for that, I have a handy custom SQL. So I'm going to grab a custom SQL pill from MySQL, just kind of to follow custom SQL pill is per connection. So I'm going to get it from MySQL, and I'm going to drag it over the MySQL table. I'm not going to add a new one. If you drag over, it replaces tables. I'm going to paste it here. As you can see, I have a cast on a column to a desired data type. So I put it over, so it replaced the table and made our join happy. So here you saw probably spinner a bit longer. This was, again, us going to database, fetching 500,000 rows from one side and a couple of thousand rows from the other side and joining them in Tableau. And it was customers. So far, so good? You with me? Good. OK. Now, the Excel file I joined earlier, this time I made it a bit dirtier. So table is offset. Let's see what happens with that guy. I'm going to drag it in. I have a zip code on the customers I want to join. If you guys work with Excel files, this is something familiar to you. Like, we could not find a table at the first. But we do have Data Interpreter, which is allow you to extract tables from Excel files. So I'm going to click that. And now Tableau was able to find a proper table, so now I can join. Before I get to the type mismatch again, so you can do operations on files, which is like cleaning independently of whether they are in the cross-database join or not. So this is available to you still. So now we're dealing with Excel file. It tells me that my customer zip on the left side is in a string. It's a number, which is a proper thing on an Excel table. So to fix that, I'm going to find, using handy colors, that zip code table. And I'm going to change the type from a number to a string just to satisfy the condition on the left. I can fix it by writing custom SQL, but if you're dealing with text and Excel files, it's very easy to just click and do it with the UI without any code. So changing time, fix the join, we're all happy again. And just to finish up here, I'm going to show it with the union as well. Here I'm joining product ID and product ID. Columns and questions are product ID. And where is that? Oh, it's red. Where's red? In this case, I'm going to make it double. So it fixes it for one table. And once you bring in the union, you don't have to do anything. We apply it across the board. So you don't have to do it per file. Was that it? Let's see. Any questions on that? Ooh, yes.
Go back to the data interpreter. So what did you do actually?
Go back where?
The data interpreter for Excel.
Yeah, so basically Excel file was not clean. So if we just look at the A1 cell, we don't see a table. We just take it as it is. If you turn on Data Interpreter, have you used it before? OK, that's why it's probably. Data Interpreter is a feature that was introduced probably a couple of versions ago, 9 something. It allows you to find tables in Excel sheet. If you, like, it works in the case that you have multiple tables in one Excel sheet. We'll be able to find all of them. There are at least one talk on that. That's really cool. That's done by a developer who created it. There's a very sophisticated logic behind it. Yes, so we're able to find the table, whatever that is, not just at the top, which is very common. You had a question. Go ahead.
I noticed when you had the zip code mismatch.
Yes.
When you had mismatch, you went and changed it on the Excel file rather than on.
Yes.
Are you not able to edit it from the SQL to the number?
I can edit to the number. I would have to write a custom SQL or go to the database and actually fix this.
Do the handy drop down thing?
Correct. This is what I mentioned before. So the drop-down type change only works at basically underlying data level just for text and Excel and Google Sheets. It's only because we have actually ability to reparse the data and bring it in our format. For everything else, we don't push casts into the join, and type that you apply only bubbles up in the select statement, not in the join keys. Make sense?
Yeah. And that that was new, you don't do the casting with the multiple, the cross-database joins, but it did before?
No, 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 no. It was always the case. It was never an issue because before, if you were able to join whatever it was, we never touched the join keys anymore. Like if you join integer and integer, and you say like customer ID and customer ID, and then you say in the viz, my customer ID is a string, it only shows up as a cast in a select cast customer ID is a string, and the join keys remain intact. This is one of the, we were thinking about doing the same functionality for regular fields, but it would introduce a huge problem for existing customers that change type to desired ones, and we don't want to push them to the join and break their relationships. Yes?
So if I bring a table from SQL and then another table from Oracle, I can convert that to custom SQL. I understand that's by design.
Yes, because it does not make really sense. Like it's two different systems.
So I want to change the data type
Yes.
to one table, right, to convert it.
So yeah, so the custom SQL is per connection. So you can express join of multiple multiple tables of Oracle, but you cannot write a custom SQL that will say join MySQL in Oracle.
Would you guys consider that?
That's no, we would not. Just because it's a custom SQL is meant for a vendor-specific functionality. Because you're dealing with syntax and just the fact that we would have to actually pull the data together.
So if I bring the custom SQL and then I drag another table and there's a data mismatch and I want to convert it at the same time so I can edit the custom SQL, it did allow me in 9.2, but it doesn't allow me in 10. Why is that? So basically, it's from the same one data connection, but I have a custom SQL and I drag one table. I just want to convert it so I can do it at just one shot.
Okay, so you want to have a custom SQL table and you want to convert it to higher level custom SQL?
Yeah, so I can do interchange instead of doing multiple.
I'm not sure if it was ever supported, but I will try. I'm actually curious now. Yes, we can take it offline. Okay, now you have a hopefully good, nice join in front of you. Data is merged together. Next couple of slides, we're going to go over slow joins or why it could be slow and potentially what can you do to address that. Big topic that was sort of introduced for us, or we introduced it, is order of join table matter. By order, I mean order in which you drag in tables into the join canvas. The official definition that at least we explained to each other. Let's see if you will probably have to explain it again. And the first set of tables you'd add from a similar connection are treated a bit differently. That means we're going to process them at one single join. So we're going to take that join and we're going to push it to a remote database. Once you add a first table from another connection, we'll break an assumption and everything that's joined after it will be queried individually. So again, first set of tables, it's a remote join. We get it to SQL or MySQL. And everything else is going to be select table and select another table, select another table. This is coming from our assumption that the left side or initial set of data that you add is going to be your big fact table. And we try to optimize for that and actually let database handle most of it. And then you're going to tackle on small dimension tables from other places. This is the main scenario we're building this feature initially. So now we're gathering feedback in terms of did we hit the mark or not. So again, feedback is really important for us. Example for this. So imagine you have this join. So there are two connections in place, as you can see by the color, so blue and orange. And numbers is order in which tables were actually dragged in and joined in. So it was table 1, 2, 3, 4, and then 5. So I had one connection, I was doing that. I switched to the second one, and then I came back to first connection and added the third table, or table 5. So physically, how Tableau will query this information is this. So first, we're going to go and get the data from table 5, from the blue connection. Then we're going to get and fetch table data for 4, then for 3, then we're going to push join for the first connection for table 1 and table 2. Questions here? Good. So why is this in the slow join slides? The big reason is, imagine you're filtering on your dimension table, and you add it in this way. And you added some filter that will reduce, or supposed to reduce the data size of your data set. The way we will do it in this case, you're going to put a filter on table 5. You're going to bring, instead of 100 rows, you're going to bring in 20 rows or 5 rows. We're still going to bring in the whole fact set from table 1 and table 2 independently. And then we're going to join it locally, and then the filter will actually kick in effect. So this is something to watch out for when you're applying filter. Because of this, because of the way we bring in tables individually, the data set that if you're trying to minimize the data set that you're moving in from one place to another, you actually have to aim for the big fact tables, or at least make sure they're linked together with a dimension table that you filter. Yes?
So what you're talking about would apply if we were doing an extract and we were trying to filter our data set down by that 5th table. It wouldn't actually reduce the length of our query. Like our end data set may be smaller, but our initial query is going to be the same size because it still has to pull the information from 1 and 2.
Yes, so the question was, is it affecting the data size that move around before we create an extract? The answer is yes. It's only going to affect the resulting extract size as it's materialized on the disk. You had a question back there?
Yeah, so what you're saying about pulling in the whole table and then doing any, any filters
Yeah.
or where clauses, is that just true for the right tables, or is that true for all tables in cross-based drawings? Like, is that going to be true for T1, T2, T3, T4?
So the filter will be applied, but since when we query data, it's just joined queries, so it only be applied on set of tables or a table that has a filter on. So if you're going to put filter on table 2, it's going to be part of the join, so it's going to be select star from A, or table 1 join table B, where something from table 2.
I guess if we put a filter on table 1, would that pull in the whole table and then apply the filter?
No, no. There's a filter push down. Surprised at me. I thought I'll either mention that or remind me before I move on to the next demo. Second topic is, again, in the performance section, referential. Oh, sorry, you had a question back there?
Yeah. Did the performance recorder shed any light on the algorithm used for
It will show, the question was, will performance recorder show any insights on how it's done? It will not necessarily shed light on the algorithm. It will shed light on the visual queries that we run. It's probably not going to tell you why we chose to do that instead of something else, but it will tell you what we did. How many of you heard of Sorry. Can we park it? I'll sync with you later. How many people heard of referential integrity? Wow. It is advanced class. Just to remind everyone, a very old feature that basically tells Tableau that all your joins are performed on the primary foreign key relationships. Like every row from the left table or left tables will have exactly one match in the right tables. If you have this case, yes, when it comes in play, imagine you have this data set, two tables, you're joining them on the customer ID. If you want to answer the question sales per customer category, we have to join them because this is the data that we need. And you can see it's one row on the left has exactly one row on the right. So in this case, we need to bring everything. If you need to answer this question, which is what are my sales per month? In this case, we don't need the right table. And we can optimize our queries and don't include it in the join. And only query orders table. So what it gives us is it gives us an opportunity to do a more, what we call it, join calling. So basically removing unnecessary tables from the join. For a single connection, this information comes from a primary foreign key relationships. In cases where it's not available, for example, like you're joining text files that don't have keys, or something else, or cross-database joins for that matter, that's why it's here, you have to give Tableau an extra hint and actually set that flag. So it's all or nothing. So the setting applies to all the joins in the tables. So use it with caution. But a lot of you actually know what it is. And the last one, so it's an old feature, so there are many blog posts and articles about this, so read up on that and try it out. And if your data set complies, it will give us more information to optimize your joins. Takeaway, as Ding Ding mentioned, data movement takes time. So we need to minimize as we can. When we did measurements in-house with various scenarios, the time spent on moving data, basically select star from somewhere, accounts for way more than half of the time that we do to run the joins. Tableau data engine that then joins the raw data looks pretty fast, but the pulling data down is costly. Use filters whenever possible, taking into account the clustering of the join, how we spread the joins out, and apply them where that matters. So aim for fact tables, not dimension tables. Scope calculations to a single connection. This is sort of touching base on push down. If you have a calculation that says, give me a length of a customer name, length of string. If you try to do that, we're not going to bring in a string if you don't use it in a biz. We're going to push calculation down to the database, so you can do that. Same applies with filters. Just to touch back, if you say, give me only the orders from 2016, we're going to push it down to the back end, and we're not going to bring all the rows. So live mode is encouraged. Extracts are recommended once you past a certain threshold of data size. Again, as Ding Ding mentioned, with, I guess what we call medium data, it's pretty fast. And since in Tableau we at least we prefer interactivity more, if you're actually dealing with data set that's pretty large, since every interaction will pretty much generate a new set of queries, we'll have to bring in the data again and join it again. So if you're dealing with that situation, when your interactions go over your mental limit, consider using extracts. Because once you have the data in, everything else as it was since Tableau 6, or it's basically as pleasant. Yes?
What do you consider small?
Yeah, so for us, here I have 500,000 records. I don't notice that I'm doing something special that I didn't do before. And again, it depends on not as much as the row count, more of like a width. If you're pushing large strings over the network, it's way worse than pushing numbers. Nothing new, but hide unused columns or unused fields. It doesn't really matter for live queries. We're pretty smart of not bringing in anything we don't need. But for extracts, everything that you don't hide will be materialized. So we'll query for it and we'll bring it in. Do we have a time for a demo? We don't? Cool. Sorry. Back to you, Ding Ding.
All right, now let's take time to look at what we are going to offer in the very near future. And this is not something up in the air. This is something we already start working on. So first of all, we definitely add more connections. During the 10.0 beta timeframe, we got high demand to add Salesforce and publish data source into the mix. So you should be able to cross-database join with those two connections. We want to add more flexibility and capability of what you can join to. One of them is join on calculations, such as cast, split, etc. So this is the right solution to the data type mismatch. With join on calcs, you just simply cast your column into the correct type, and you join together. No need to go through the custom SQL anymore. More optimizations. One of them is aggregates pushdown. We want to push aggregate functions, min, max, etc., as applicable as we can, down to the remote database you have, and we will only pull in the data after the aggregation, which will reduce the data movement, and as a result, you get a better performance. We also build in more parallelism in the query processing at Tableau side, so can speed things up. Lastly, but very important, is the one of the big things we're working at right now is called alternative integration engine. Just a reminder, what we mean by integration engine is a place where the join happens. For example, you have 1 billion rows in your Teradata, and you want to cross-database join with a tiny Excel sheet, 100 rows. What about we don't need to move all those 1 billion rows from Teradata and then 100 rows from Excel and join in Tableau? What about we just pull this 100-row Excel sheet and push down to Teradata and join right there? You can imagine the data movement is minimized and performance is really optimized. This is exactly what alternative integration engine will be doing. So alternative integration provides you the flexibility to select a database engine you already have in-house, maybe a powerful database processing engine, and we will have the join happen right there. So the flow is very similar to what is today with one key difference. So first of all, you select the database engine you want to use as integration engine. In general, we recommend select the one with most of data in it, so you don't need to move those data at all. Then Tableau will move the rest data, usually recommended as if you select the big database engine. Hopefully, we only need to move the minimum data that's needed to Tableau and then push down to the database engine where you have the majority data in it and join right there. So afterward, all your viz, all your report will just be querying this database as what do you do today, and you're good to go. We did experiment. We had a prototype, and we already observed the performance is very promising. If you're excited about this new feature, watch out for the beta offering coming soon and sign up and provide us with feedbacks. So let's do a very quick recap. So we talked about what this feature is and why we need it, because we need to join data from all different kind of places, and how this is implemented and what's the design behind it, and all the scenarios Dimitri went through to help you to make best out of this feature. And we also presented what you can expect in the future.
When you tried that on the data engine, what was the impact of the system requirements? I'm thinking memory.
So it depends. This is a good question. So basically, the question is, what's required of the system in order to be an integration engine? So this all entirely lies on your own hands. You need to have a good understanding of your data and a good estimate of how much data will be moved into that database engine. As a minimum, you need to have a space to actually host those data and join there. So, all right, so this is a related session you can go to with all those different topics around join and union and data interpreter. And please please remember to give us survey and feedback so we can improve on our next talk. And I think we had enough questions. And if you want to follow up with us, we will be at the data kiosk. And here is our contact info.
Yes. Oh, thank you.
Thank you.
There's a question.